Hey, good people. Arthur Morris here. I hope all is well. In this video, we are going to look at the derivative and the tangent line problem. So we'll look at finding the slope of the tangent line to a curve at a point and using the limit definition to find the derivative of a function. All right, so here you see that we have a secant line drawn through a curve and it touches that curve 2 times. And we have the change in x and change in y. So you know the slope of that line will be the change in y over the change in x. As that change in x gets smaller and smaller and smaller, this line gets closer and closer and closer to being a tangent line. So as the change in x approaches 0, we end up with a tangent line, in this case it's c of f of c. And that tangent line gives us the slope of the curve at this particular point, and that's what we call the derivative. So based on the slope formula, m equals y2 minus y1 over x2 minus x1, we can write this in terms of f of c and delta x, where we're using the c from that point. So still y2 minus y1, so f of c plus delta x minus f of c, and you see that from here as your x and y, f of c plus delta x minus f of c all over c plus delta x minus c. So it just uses the slope formula there. Okay, so we're going to use this definition of a tangent line with the slope of m. It says if m is defined on an open interval containing c, and if the limit of delta x over delta y as delta x approaches 0 equals the limit of the function of c plus delta x minus f of c all over delta x as delta x approaches 0, then that equals the slope. And the slope exists in the line passing through cf of c with the slope of m is the tangent line to the graph of f at the point cf of c. So the first thing we're going to use is this formula here to find our slope of the tangent line to the graph of a function at a given point. Now you will also see me write this, depending on what we're given, f of x plus delta x, because c is going to be in the place of an x point, so minus f of x all over delta x, and that's most of the time. I'll write it like that most of the time just to, because that's something we are familiar with. Okay, so I want to find the limit as delta x approaches 0, and I'm going to write it in the x form of f of x plus delta x minus f of x all over delta x. And I'm treating this as x. We're given a point, and you can see it as c and f of c. I'm just going to write it as x and f of x. So we're given that point of x and f of x. Remember, f of x is the same thing as y. All right, so let's see what we have here. Let's start filling this in a little bit. Our function is 3 minus 5x, so let's keep that in mind. Let's go ahead and replace x and f of x with what we are given. So f of negative 1 plus delta x minus 8, because we're given that point there at delta x. Oh, sorry about that. Let's see here. All right. So now let's substitute in, replace this function using the function of x, 3 minus 5x. So f of x is equal to 3 minus 5x. That tells me that everywhere that I see an x in that function, 3 minus 5 times x, I need to replace it with -1 plus delta x. Okay, so I have 3 minus 5 times x is my function. Inside here I have -1 plus delta x that's in the place of x, so I'm going to replace x with -1 plus delta x. Keep the -8 and divide it by delta x. So I just use the function 3 minus 5x, and since we had f of -1 plus delta x, replace x in the function with -1 plus delta x. All right, and then let's simplify this. So let's distribute that -5. Okay, all over delta x. Alrighty, let's simplify this a little bit. So we have 3 plus 5 is 8, and 8 minus 8 is 0. So that leaves me with -5 times delta x over delta x. So -5 times delta x all over delta x. And then I can simplify that just a little bit more by canceling out those delta x's. So the limit of a number is just that number. So the limit of -5 as delta x approaches 0 is -5. So the limit of this function at -1,8, or the limit of this function at -1,8 is -5. So that is our derivative, or the slope of the tangent, the line tangent to 3 minus 5x at the point -1,8. Now, given that this was a straight line, 3 minus 5x, and you know about y equals mx plus b, the slope always for this line is going to be -5, because it's a line and we know how to find the slope. And you see that we did come up with -5 using that formula. Alright, so this next one we have g of x equals x squared minus 9, and we're given the point 2, -5. So I'm going to label the 2 as x and the -5 as y, or f of x. In this case, g of x. All right. So I don't want to confuse you. That really should be c and g of c, but I'm just going to leave it like it is here. All right, so let's see here. All right, so let's rewrite this. The x in this case is 2. And then when x is 2, then the function is equal to -5. And all over delta x. Okay, so from there, we are going to use our function to rewrite the g of 2 plus delta x. And we know that g of x in the function form is equal to x squared minus 9. So in the place of x, we need to put the 2 plus delta x. So that's 2 plus delta x squared, because x was squared, minus 9, and then plus the 5 that we have here. Alrighty, let's simplify the 2 plus delta x squared by using our special multiplication rule that says a squared, or 2 squared, is 4, plus 2ab, 2 times 2 is 4 delta x, plus b squared. And you can use distributive property, 2 plus delta x times 2 plus delta x, or you can use your 2 plus delta x squared, which says a squared plus 2ab plus b squared. And then negative 9 plus 5, that's negative 4. Alrighty, so the 4 and the negative 4 will cancel out. And I can factor out a delta x from what's left. So let's see. So factor out a delta x. We end up with 4 plus delta x all over delta x. And then those delta x's will cancel each other out. So now I have the limit of 4 plus delta x as delta x approaches 0. So going back to using our limit rule, the next thing we would try to do is to substitute. So I'm going to replace the delta x with 0, since we're finding the limit as delta x approaches 0. So 4 plus 0 equals 4. So again, what that's saying is, if we were to draw this parabola here, x squared minus 9, place the point on there at 2, negative 5, then the line going through that point that's tangent to this particular curve, a line tangent to the curve there, the slope of that line is 4. The slope of the line is 4. And slope, remember, that means that that's going to be rate of change. So derivative is rate of change. So you're looking at this as, you can look at it as speed variation, as speed varies at any particular point. If we can find the line tangent to the curve at a particular point, then we can find the slope of the line or the rate of change at that particular point. All right, so now we're going to look at finding the derivative by the limit process. So we're going to use the same thing, except we're not given a point. So we're just finding the limit based on using this limit process. All right, so we have f of x equals 7x minus 3. Okay, so let's see here. We have f of x plus delta x minus f of x all over delta x. So let's go ahead and write this function out, replacing those, the f of x plus delta x and the f of x. All right, so the function is 7 times x. In this first part, we will replace the x with x plus delta x, and then minus f of x minus that entire function, which is 7x minus 3, all over delta x. So I just substituted in there for that function, those function values, and now I'm just going to simplify. All right, so distribute, distribute, distribute. So let's distribute that 7, and gives us 7x plus 7 times delta x, and distribute the negative. So don't forget, if you have a minus in front of a set of parentheses, you have to distribute that as if it is a negative 1. All right, so from here, let's simplify. Let's see, so I have this 7x and that negative 7x that cancels out, and I left out something. Sorry about that. So let's go back here. When we replaced this function 7x minus 3, I left off the minus 3 from that original function, then minus 7x minus 3. So let's put that minus 3 in there from here, and then minus 7x plus 3. All right, so the 7x and minus 7x will cancel out. The negative 3 and the positive 3 will also cancel out. So that leaves me with seven times delta x all over delta x. And you also see that the delta x's cancel each other out, and the limit of 7 as delta x approaches 0 is just 7. Again, you can look at this, you see it's a line, f of x equals 7x minus 3. Now I encourage you to practice the process, but also know a different way of finding that the slope of that line is always 7 because of y equals mx plus b. Now we will go through a easier way to find derivatives, but that will be in another lesson. So make sure you practice the limit definition here. All right, so find an equation of a tangent line. In this problem, we have an equation of the line that is tangent to the graph, or we want to find an equation of the line that is tangent to the graph of f and parallel to the given line, in this case, which is 4x plus y plus 3 equals 0. So one thing to know about parallel lines is that parallel lines have the same slope, right? So first of all, I want to find the slope of each one of these. The f of x equals 2x squared using the limit process, and the slope of f 4x plus y plus 3. I want to find the slope of each one of those. Okay, so I'm going to go back up where I have some scratch paper and find the slope of f of x equals 2x squared using my limit process. So let's go back up here and find the slope of f of x equals 2x squared. Using our limit process. So you may want to pause the video here and see if you can find the slope of it. And I would love to substitute a 0 in here, but that means I will be dividing by 0, so I can't do that quite yet. So let's see here. So we have x squared plus 2 x times delta x plus delta x squared minus 2x squared all over delta x. All right. And then that gives us 2x squared, use our distributive property, plus 4 times x times delta x, plus 2 times delta x squared, minus 2 times x squared all over delta x. All right, the 2x squared minus 2x squared cancels out. Looks like I can factor out a delta x and run out of space here. Let's go back up here. So I can factor out a delta x, which will leave me with 4x plus 2 delta x all over delta x which allows me now to cancel out a delta x from the denominator, which is great. So now I can substitute in. So I have 4x plus 2 times 0, which equals 4x. Okay, so the slope of f of x, or the derivative of f of x, equals 2x squared is simply 4x. And we're going to write that in what we call prime. When you see a dash here, that means f prime of x, or the derivative of the function, equals 4x. So that's just another notation. F prime of x equals 4x. That means the derivative, just another notation. Alrighty, so we did all of this work here to find the slope at any given point on that curve. So now we need to find the slope of this line. So let's subtract the 4x and the 3, and using y equals mx plus b, we know that the slope is equal to -4. Alright, so the one thing that we know about parallel lines is that their slopes are equal. They have the same slope. Therefore, I'm going to use that information to help me find the point for the line that's going to be tangent to the curve that will be parallel to the given line. So now, after I found those slopes, I'm going to set the slopes equal to each other. So set the slopes equal to each other, and that will put me on the path to finding the point of the line that's on the line that's tangent to this curve that's also parallel to the given line. Alright, so f of x, f prime of x, we know equals m. Therefore, 4 times x equals -4. Therefore, when all of this is, when we're looking at all of this together, that point has an x value of -1. And if it has an x value of -1, we're still looking for a point on this curve here. Then I'm looking for f of -1. Y is going to be equal to, y would equal f of -1, which equals 2 times -1 squared from our function there. Therefore, the y coordinate when x is -1 is 2. Alright, so I know that the point on the curve that the tangent line is going through that will be parallel to the given line, that point on that curve is -1, 2. So -1, 2 is the point on the curve that the tangent line is going through that will give us a line that's parallel to the given line. Now our question asks us, or our instructions ask us, to write the equation of a line that's tangent. So the equation of a line, to write the equation, we're going to use point slope. So y minus y sub 1 equals m times x minus x sub 1. We know that the point is -1, 2, and we know that the slope is the same as the slope of the given line, is -4. So if I plug that information into our point slope equation here, formula here, then I can find the equation of the line that's tangent to this parabola that's also parallel to the given line. So let's replace x1 and y1 and m. Okay. So minus -1 makes x plus 1. And if you were able to leave it in point slope form, that's that. If they want it in slope intercept, then you know you need to distribute and move the -2 over. So That's point slope where I just boxed in. Subtract 2 from both sides. Oh, sorry about that. Sorry about that. Subtract 2 from both sides. Not sure what's going on with this computer, but we're about finished. And you get negative 4x minus 6 here, or add 2 to both sides. I'm sorry, I'm getting a little tired here. Add 2 to both sides, and that will give you negative 4x minus 2. Y equals negative 4x minus 2. Alrighty, and that's it for that type of problem. Next problem we have here is the alternative limit form of the derivative shown, and the alternative limit form is f prime of c is equal to the limit as x approaches c of f of x minus f of c all over x minus c. Okay, you can use the alternative form of the derivative, or you can just let's go ahead and do it just for good practice. So let's see here. So f prime of 3 would be equal to the function f of x, so x squared minus 5, minus f of c, so let's see, 3 squared minus 5, using this, replacing x with a c, and c is equal to 3. All over x minus c. So all over x minus 3. Alrighty. And let's keep simplifying that. And this is as the limit of x approaches 3. Okay, so you have x squared minus 5, and then you have 9 minus 5 in here, which is 4. So minus 4 all over x minus 3, and then x squared minus 9 all over x minus 3. And then you have x plus 3 times x minus 3 in your numerator. And this is just another form of finding your derivative, another method you can use. And then the x minus 3's cancel. So you end up with, by substitution, 3 plus 3, which equals 6. Okay, so all of this is substitution and practice, really a lot of algebra practice here. Okay, so let's see what we have here. All right, the next problem we have is using a graphing utility, and again, you can use desmos.com as your graphing utility to graph the function and find the x values at which f is differentiable. So wherever f is continuous, that's where it's differentiable. So let's find where it's not continuous by finding our domain, and we look at our denominator to help us find our domain. We have x minus 3. So if we set x minus 3 equal to 0, we get a vertical asymptote at x equals 3. So looks like right about here we have a vertical asymptote. So we know that this is continuous at everywhere except where x equals 3. So to write this in interval notation from left to right, This will be continuous from negative infinity to 3, parentheses because we're not including 3, comma, the other side of 3, all the way to positive infinity. And that's where it's differentiable because that's where it is continuous. Alrighty, good people. I hope you found this video to be helpful, and I will see you on the next one. Thank you.